Hi, so in this part, we're going to talk about complementary events and disjoint events and just see the formulas that are involved because we've been talking about the probability of an event occurring. So we just want to talk about how about an event not occurring or talk about an event occurring with disjoint events or mutually exclusive events. So the first thing we want to talk about is the complementary events. And complementary event is just um, the where the event does not occur. So if we have an event E occurring, then the complement would be that E does not occur. We denote the complement by an E bar, and the formula is given by the probability of the event not occurring is equal to the 1 minus the probability of the event occurring. But we can always play around with these numbers here because these are just fractions. And so if I move this one over to the left and this one over to the right, I get this formula on the third bullet. And the probability of the event occurring is 1 minus the probability of the event not occurring. So if I just take the Bucky's deck of cards, what is the probability for Satchel not to draw a queen? So right away I can see the word not and know that, okay, this is going to be some sort of complement, right? And so the event E itself will not be not to draw a queen, but to draw a queen. And so the complement of that event is not to draw a queen. So the probability of E complement is going to be equal to 1 minus the probability of the event occurring. So 1 minus the probability of the event occurring is just the number of ways Satchel draws a queen, right? And then all over the total number of outcomes. Now, when we do this, we know that it's going to be 1 minus the number of ways to draw a queen. Well, that's a type of card, and there's only 4 queens out of 52. And so if I went ahead and did this would be 48, right? I would just do 1 minus 4 over 52, which is 48 out of 52. And if I reduce that fraction, it would be 12 thirteenths. Okay, but if we wanted to talk about in conversation, we could go ahead and use our calculator. So let's go ahead and go to our calculator and we can do 1 minus 4 out of 52. And it knows what to do. It gives this decimal. Now just go to math and go to 1, which is to fraction. And what it'll do is just take this number right above and take it to a fraction in the most reduced form. So 12 thirteenths, 12 thirteenths. And if you wanted the decimal, we would say 0.9231, which is 92.31%. So the probability that Satchel will not draw a queen is about 92%. Or essentially, if I draw 13 cards, 12 times I will not, 12 out of the 13 times it will not be a queen. And so we just want to make sure that when we do the problem, we subtract correctly and make sure you can use your calculator, or if you do, make sure you subtract fractions correctly. Other than that, those are the 3 ways you would always give your answer as a reduced fraction, approximate decimal, or approximate percentage. Okay, and again, I want to emphasize that the word not goes with the complement. So when you see the word not in a problem, you automatically think of this is going to be the complement formula and you do 1 minus that probability. And this formula is all laid out in the formula sheet for these notes. Okay, so next we want to talk about 2 disjoint events. And disjoint events just means there are no outcomes in common. And another name for that is mutually exclusive. Disjoint is and mutually exclusive are interchangeable, and you can use them as how you prefer. Now, in order to understand disjoint events, I'm going to go back to the deck of cards. And so that way we can see and understand that disjoint events just means there are no outcomes in common. So if I said I want to draw a club and I want to draw a diamond, notice that there is no overlap here. And there are no outcomes in common. If a card is a spade, it cannot be a heart. And if it's a heart, it cannot be a spade or a club, right? But if I said I wanted to draw a heart and then a queen, well, now there's some overlap. With the type of card and with the suit of card, there is an overlap between a queen and a heart, the queen of hearts. So that wouldn't be disjoint because we do have outcomes in common between the heart and the queen. Now, this is for any type of card. Any type of card that intersects with a suit will have overlapping outcomes. So the only way we don't get overlapping outcomes with the deck of card would be if I ask for two suits, right? So if I ask for a queen and a 7, there's just no overlap there because a queen cannot be a 7 and a 7 cannot be a queen. Or two suits, right? A club and a heart. So anytime that there's just overlapping outcomes, they're not disjoint, and we cannot use the formula for disjoint events. So the formula for disjoint events is just the probability of two events occurring, right? So the A and B, so the probability of either A or B occurring is just the sum of each of the probabilities. So we assume when you say the word disjoint, that we assume that there are no outcomes in common. And so in this next example with Bucky and the standard deck of cards, we see that he wants Satchel to draw a card and then he puts it back in the deck. So if he finds Satchel drawing a card, what is the probability that Satchel draws a queen? Well, the probability of drawing a queen is just the number of ways we can draw a queen, which we just saw was 4 out of 52. So that's just 1/13 if I reduce the fraction. The next one is the probability for Satchel drawing a spade. So what's the probability of drawing a spade? Well, that's just the number of spades I have in the deck out of 52 cards. And so I have 13 spades, or 13 of any suit, right, out of 52, which is 1/4. Now, when I get into the next example, I say, what is the probability of drawing a spade or a heart? So there's a couple of red flags here. So the first one would be or, and I automatically think of disjoint events or the addition rule, right? So disjoint or plus, right? Add. And then I think, okay, well, are these disjoint? And so we assume we are disjoint because we are doing the disjoint formula. So let's just do it. The probability of a spade or heart is equal to the probability of a spade plus the probability of a heart. Now, why are these disjoint? We know they're disjoint, right? Because you told me. No, because there are no overlapping outcomes, right? Because no outcomes in common. And just always think of the overlap, like, oh, can A be B and B be A, right? And so can a spade be a heart or a heart be a spade? No, right? So the probability of a spade would be 1/4 because we just found it. And then 1/4 again because there's 13 out of 52 hearts, which gives you the same probability as above. And that's going to be 2/4, which is 1/2, which makes sense because two suits together make up half the deck.